التسليح ES600 عالي القوة بمشاركة جامعة الإمارات وبلدية مدينة أبو ظبي، ممثلة بإدارة تراخيص البناء وممثلي المنشآت الصناعية، وبحضور المكاتب الاستشارية وممثلي شركاء المقاولات، والتي سنستعرض من خلالها آخر المستجدات في هذا الأمر من خلال أفلام وأوراق عمل ونقاشات نتطلع من وراءها إلى تحقيق أهداف ورشتنا في مزيد من الاطلاع والتنسيق وتطوير آليات عملنا المشترك. فأهلا وسهلا بكم جميعا في بلدية مدينة أبو ظبي.
Assalamu alaikum, ladies and gentlemen, distinguished guests and respected attendees. On behalf of myself and the senior management of Abu Dhabi Municipality and all its members, we welcome you to this specialized workshop on ES600, high-strength steel. We are pleased to have an effective participation from Abu Dhabi Department of Economic Development, UAE University and Abu Dhabi Municipality, represented by Tarakhis, as well as several representatives and consultants from various industries and contracting firms. During this workshop, we will review the latest development revolving around the topic through in-depth analysis film segments, documented reports, and open discussion. We look forward to achieving the objectives of our workshop by identifying key dynamics from today's discussion, which in hindsight enable our stakeholders to better develop our work mechanisms around the ES600 rebar based on your feedback and comments. So once again, we welcome you all to Abu Dhabi Municipality.
السيدات والسادة، نفتتح أعمال ورشتنا اليوم بكلمة للسيد محمد سالم العفاري، نائب الرئيس التنفيذي الأول للتسويق في شركة حديد الإمارات أركان، فليتفضل مشكورا.
We begin today's workshop with an opening speech by Mr. Mohammed Salim Al-Afari, Senior Vice President of Marketing at Emirates Steel Arkan.
بداية صباح الخير لكم جميعا وشكرا لانضمامكم لنا في هذا اليوم. أود أن أبدأ بتوجيه الشكر لبلدية أبو ظبي ودائرة التنمية الاقتصادية في أبو ظبي ومجلس أبو ظبي للجودة والمطابقة لتنظيم واستضافة هذه الورشة المهمة حول منتجنا الجديد من حديد التسليح عالي القوة والذي أطلقنا عليه ES600. ويسعدني أن أرى مثل هذه المجموعة المتنوعة والمتميزة من المشاركين من مختلف القطاعات، بما في ذلك جامعة الإمارات العربية المتحدة وإدارة تراخيص البناء، الذين يشاركوننا رؤيتنا لتعزيز الحلول المستدامة والمبتكرة لقطاع البناء. حقيقة أنا متحمس لأوراق العمل والحلقات النقاشية التي سيشارك فيها كل من الدكتور أمان الموافي والدكتور تامر المعداوي والمهندس سعيد الفهيم، والتي ستساهم بلا شك في إثراء هذه العملية. كما يسعدني أن أرحب بجميع الشركاء من ممثلي المنشآت الصناعية والمكاتب الاستشارية وممثلي شركات المقاولات. الحضور الكرام، نحن في مجموعة حديد الإمارات ملتزمون بإنتاج الحديد ومواد البناء الأخرى بشكل مستدام وآمن، وكنا دائما على وعي بالحاجة إلى الاستدامة كأساس لأعمالنا. وبناء على هذا الالتزام طورت شركة حديد الإمارات أركان حديد تسليحي ES600 عالي القوة داخليا كمنتج مبتكر يساعد على تقليل استهلاك الصلب في البناء بنسبة قد تصل إلى 20%، مما يوفر فوائد كثيرة من حيث التكلفة ويوفر قيمة للصناعة المحلية. كذلك سيكون لاستخدام المنتج ES600 دورا محوري في انخفاض استهلاك حديد التسليح في الأعمال الإنشائية، وبالتالي تقليل انبعاثات ثاني أكسيد الكربون الناتج من العمليات التصنيعية، بالإضافة إلى التقليل من الأعمال اللوجستية المرتبطة بنقل الحديد والقطع وثني والثاني كذلك، لننعم ببيئة أنظف وأقل من ناحية البصمة الكربونية، إضافة إلى توفير المواد للأجيال القادمة تماشياً مع المبادرة الاستراتيجية لدولة الإمارات العربية المتحدة لتحقيق الحياد المناخي بحلول العام 2050. نحن على ثقة من أن حديد تسليح ES600 عالي القوة لديه القدرة على تغيير قواعد اللعبة في صناعة البناء والتشييد، ومع تحرك العالم نحو حديد تسليح الأقوى في البناء، من المتوقع أن يقود حديد تسليح ES600 صناعة البناء إلى المستويات التالية في إمارة أبو ظبي وباقي إمارات الدولة. أؤكد بأننا نحن في شركة حديد الإمارات أركان ملتزمون بتطوير وإنتاج حديد تسليح ES600 عالي القوة في دولة الإمارات، ونعتقد أن هذه الورشة هي فرصة رائعة لمشاركة معرفتنا وخبراتنا، وكذلك للتعلم من أقراننا وشركائنا. ونأمل أن تساهم هذه الورشة في تسليط الضوء على حديد تسليح ES600 عالي القوة والتأثير الكبير الذي سيحدثه في العمليات الإنشائية والبناء الأخضر المستدام في الدولة. الحضور الكرام، تشجع مجموعة حديد الإمارات أركان المصممين والمطورين والمقاولين في الدولة على معرفة المزيد عن هذا المنتج المبتكر، وتشجع أيضاً استخدامه في المشاريع المستقبلية من أجل الاستفادة منه في كافة النواحي الاقتصادية والبيئية. كما أود أيضاً تسليط الضوء على أهمية التعاون والشراكة في تحقيق أهدافنا المشتركة، وأدعوكم جميعاً لمشاركة أفكاركم واقتراحاتكم للتغلب على التحديات واغتنام الفرص في هذه الصناعة سريعة التطور. في الختام، أود أن أشكر بلدية أبو ظبي مرة أخرى على تنظيم واستضافة هذه الفعالية، كما أتقدم بالشكر الجزيل إلى دائرة التنمية الاقتصادية ومجلس أبو ظبي للجودة والمطابقة وجامعة الإمارات وإدارة ترخيص البناء لدعمهم لهذا المشروع. ولا أنسى أيضاً أن أشكر جميع ممثلي المنشآت الصناعية والمكاتب الاستشارية وممثلي الشركات والمقاولات لتواجدهم معنا اليوم. والسلام عليكم ورحمة الله وبركاته.
في فقرتنا التالية نتابع بصحبتكم مادة فيلمية تسجيلية حول صرح صناعي رائد في إمارة أبو ظبي، حيث نشاهد معا أهم منتجات حديد الإمارات أركان ودورها في دعم الصناعات الوطنية ذات الجودة العالية. أرجو لكم مشاهدة مفيدة وممتعة.
For our next segment, we kindly ask everyone to turn their attention to the screen, where we will watch an informative video that provides an in-depth analysis on how Emirates Steel Arkan, the largest building material manufacturer in the UAE, produces its wide array of products and highlights its integral role in our industry and the UAE economy today.
Emirates Steel Arkan, the UAE's largest listed steel and building materials company.
6 main business units.
Steel,
Dear guests, if you would like to have any translations, please approach the entrance over there. There is a mics, there is handsets to use for the translation. Thank you.
Emirates Steel Arkan, the UAE's largest listed steel and building materials company.
6 main business units.
Steel, cement, blocks,
Dry motors,
pipes, bags. High-quality products, sold locally and exported to over 70 countries. Share of 12% in Abu Dhabi's manufacturing activity output, equivalent to 9.128 billion dirhams. A domestic market share of 60%. 3,000 plus employees, representing over 50 nationalities and with more than 600 Emirati talents. High score of 85% in the MOIAT in-country value program. World-class safety performance. Received 2 safety awards from the World Steel Association in recognition of our organization-wide best-in-class health and safety protocols. Developing a digital roadmap to optimize our production process. Driving innovation throughout the company to promote a culture of excellence. Leading the global sustainability narrative. Operating extremely low carbon footprint steel production facilities with 40% less than our global peers. The world's first steel company to capture its CO2 emissions. Studying the development of a hydrogen project to produce green steel. Promising business opportunities. Broadening product range with higher value and higher margins. Tapping into new industries to include the manufacturing sector. Increasing exports and geographic expansion. Well positioned to realize potential growth. Emirates Steel Arkan. Shaping the future.
السيدات والسادة، الآن نستقبل وإياكم المهندس حمد الخزيري ليقدم لنا ورقة العمل الأولى، وبعد انتهاء هذه الورقة سنأخذ استراحة لمدة 10 دقائق ثم نعود لاستكمال محاور ورشتنا. فليتفضل المهندس مشكورا.
Now, we welcome Engineer Hamad Al-Khazeri to present his working paper for us today. Following that, we will take a short break for 10 minutes, then return to complete the agenda of our workshop.
Assalamu alaikum everyone. Allow me to introduce myself. My name is Engineer Hamad Al-Khazeri. I'm in the Supply Chain Department of Emirates Steel Arkan, and I will be showcasing our newly launched product, the ES600. But before I start, let me start by thanking you all for being here today, and thanking Abu Dhabi Municipality for allowing us, for giving us this event and allowing us to showcase our newly launched product. Now, before I start talking about the new product ES600, let me give you a brief introduction on our company. So Emirates Steel Arkan is a publicly listed company, and since the merger that took place in the year 2021, it is now considered one of the largest steel and building materials manufacturer in the UAE. Not only that, but our high quality produced products participate in very high share markets in the steel market, with our steel product, the Rebar, holding shares of 60% of our steel market, and our steel hot rolled beam 80% to our steel market. And as mentioned in the video previously, Emirates Steel Arkan holds shares of 11% to our capital city Abu Dhabi's manufacturing output in the year 2022. We proudly say that we have a large market base with over 70 countries, including Europe, the Americas, Asia, Middle East, and Africa. Furthermore, that's all thanks to our employees of 3,000 employees with diverse backgrounds. And if you ask anyone that has associated himself with Emirates Steel Arkan, it is known that Safety is our top priority, as long as with our production, but safety is always key. And with that, we have achieved a world-class safety performance with one of the lowest LTIs in the globe. Now, as we all know that COP28 is the narrative, and the UAE will be hosting this COP28 event. Emirates Steel Arkan is also proudly leading the decarbonization program amongst the steel manufacturers in the globe. Now, let me give you give you a brief idea on our production process. We can proudly say that Emirates Steel Arkan is one of the only fully integrated plants in the Middle East. And as we all know, iron does not... So as we all know, iron does not exist in nature in its pure form. It exists in a term we commonly known as rust or oxidized iron. So in our first stage of production, our iron ore pellets go through a chemical reduction process where we separate the oxygen particles from the iron, which leaves us with pure iron, or also known as sponge iron, or DRI, the direct reduced iron. Emirates Steel Arkan has three DRP plants, direct reduction plants, with a capacity of 4.2 million tons per annum. This DRI is then transported into our steel making plants, where the iron is smelted and mixed with carbon, manganese, and other additives, leaving us with, and then this iron is casted, and that leaves us with our semi-finished goods, which are broken down into two parts. We have our steel billets, which I'll show you now in the screen, and our beam blanks. These semi-finished products are then transported to our... Sorry, I forgot to mention that in Emirates Steel Arkan, we have 3 SMP plants with a production capacity of 3.6 million tons. These semi-finished products are then transported into our final stage of production, which is the rolling mill, where this cast is heated further and it goes through stages and strands to produce our finished products. Now, I'll be talking more about the finished products in the next slide, but we have approximately 5 rolling mill plants. So hint, with our 5 rolling mill plants, we produce 5 products. Lost control. So now, let me tell you more about our steel products. Emirates Steel Arkan is known for producing a high-quality rebar that is used in construction, and it takes up majority of our production capacity of 2 million tons per annum. There also exists our rebar and coil, which is used in various different activities, in construction activities, just to increase efficiency, and it's produced upon request of the customer. We also have our wire rod product, which is considered one of the most prominent products within the GCC region, and it has a production capacity of 550,000 tons per annum. These wire rods can be used for fencing purposes or barred wires, simply. We are also proudly one of the main producers of our heavy section products, and the only producer of our jumbo sections in the region, with a production capacity of 1 million tons per annum. Now, this is one of my personal favorite products we have in Emirates Steel, and it is our hot rolled sheet piles. We can proudly say that we are the only producers of the hot rolled sheet piles in Emirates Steel, and this product can be used in various applications such as wall retainers or wall barriers in shoring activities. I'll be showing you more on where these applications have been used. Moving on to our next product, as we all know, since 2021, Emirates Steel has merged with Arkan, making Emirates Steel a one-stop shop for all building material essentials. Now, we produce high-quality cement and clinkers. We also produce concrete blocks and dry mortars, which are widely used within the local region. We also have GRP and PVC pipes, which are supplied to our local customers and exported to our international customers. We also have bags, which are used to store our building materials, which are also supplied and exported to our local and international customers. Now, let me tell you where majority of our steel products have been utilized. As you can see, yes, thank you. As you guys can see, our rebar has been used to build one of various mega projects and one of the most architectural marvels of the UAE and landmarks, like Burj Khalifa, like Museum of the Future, Dubai Frame, and one of the biggest mega projects we have, our Baraka nuclear power plant. We also have our steel sections, which were exported to our international customers in the Cameron LNG in the USA, as well as domestically used in the Dubai Expo in the year 2020 in Dubai. We also have our sheet piles, which were exported to our neighboring country in Saudi Arabia for their project of Macdermont Aramco, as well as the second Suez Canal in Egypt. Now, the reason we are stressing a lot on our market is to showcase that here in Emirates Steel Arkan, we are able to produce at multiple international norms and grades. So we can produce with the American grades, the British grades, the Indian grades, you name it. Now, in the year 2022, it was recorded that majority of our sales were done locally with a score of 61%, and the remaining sales volume were done exported to our international customers with 31%. Now, we also took a further initiative and yielded a customer satisfaction survey, which gave us a score of 80%. Now, since we use DRI in our production process, this has given us an advantage over our competitors and allows us to operate our plants in extremely low carbon footprint productions. Our studies have shown that here in Emirates Steel Arkan, our production process yields 40% less than competitors with our carbon emissions. We are also proudly the first steel manufacturer to capture its carbon dioxide emissions. Furthermore, we are also in collaboration with Taqa, we are studying the development of a hydrogen product in the initiative to transform to a cleaner energy, which will allow us to reach our net zero product, which is also known as green steel. Not only that, Emirates Steel Arkan is known for aligning its vision and motives. Emirates Steel Arkan is known for aligning its visions with the UAE leaders' targets, and that's by supporting our UAE downstream industries. This is by investing more than $1.5 billion to construct the hot rolled coil plant. This will not only benefit us as a company, but it is also aligned with the Ministry of Industry and Advanced Technologies strategy of Operation 3 Billion initiative. This can create various business opportunities for SMEs who are involved in the manufacturing industry, as well as create new jobs for the UAE nationals. Our new flat products serve several industries and applications. Now, let me tell you, sorry. Now we can finally talk about the reason we gathered you all here today. Now, what is the ES600? The ES600 introduces a new grade to the rebar family. So ES600 is pretty much a developed rebar. ES600 has a yield strength of 600 megapascal, which is approximately 20% stronger than the conventional rebar, which has a yield strength of 500 megapascal. This product, the ES600, is compliant with the ACI code, the American Concrete Institute, as it confirms with the requirements of the ASTM A615. However, it's important to mention that the limitations of the design for this product will be as per the design code, unlike the conventional rebar B500B, which is limited to 460 megapascal. We have conducted various trials with different fabricators, as you guys can see in the screen. These results have shown that the ES600 is more ductile than the conventional B500B rebar. But as you can see in the screen below, the sharp bends is not recommended as per the standard mandate, but yet our ES600 has passed that trial. We've also done a further research with the collaboration of the American University of Sharjah to test the bond strength and mechanical properties of the product. These results have shown that the ES600 performs almost similar or better than the B500B with its mechanical properties. Just like all the other rebar products, ES600 is weldable as per the AC525 clause shown in the screen. And it's only recommended to be welded with the code that is shown below, which is the AWS-D1.4. These will be further discussed with our professors joining us here today. We have also taken the initiative to meet with mechanical connector suppliers to check the convenience of this product. And as you can see in the screen, these documents show that the B500B couplers are sufficient enough for the ES600. This product was certified by the UK CARES, as well as, since the ES600 is a new product and it was not part of a design code, we have taken the initiative to approach International Code Council. To give you a brief idea on the ICC, the ICC is a certification body that can verify and certify any manufactured product and give it and certifies the product that does not have an international code. They have issued reports like the AC525 and the ESR 4800 to verify the equivalence of the ES600 to grade 90 as per the ASTM A615. This product has also been approved by the Dubai Central Laboratories, the Dubai Municipalities, the Abu Dhabi Municipalities, including Al Ain and Al Dhafra, Abu Dhabi Quality and Conformity Council, and the Ajman Municipality. Now, we are confident that this product is going to be a disruptive product in the construction industry, and it will be a game changer as well. Now, let me tell you why the ES600 is a sustainable rebar for the future. But allow me to give you this answer in the form of an example. Let's say we are trying to build a 40-story tower. Now, we've done a calculation. With using the ES600, you reduce the rebar consumption by up to 16 to 20%. And that is equivalent to reducing our carbon emissions in our production process to 4.3 kilotons, as well as we all know, we will have also transportation emissions. Let's say if we use 4 trucks to transport our B500B rebars, in using the ES600, you will be using 3 trucks, which is equivalent to reducing the carbon emissions by 40 tons. Now, let me tell you more about the parties that will be benefiting from the ES600. So, we will start with the developer and the owner. In using the ES600, you will be reducing your steel usage by 18 to 24%. That is also depending on the value engineering and the project type. 18% in comparison to the B500B rebar, and 24% in comparison to the P460 megapascal rebar. Now, also having a lighter foundation can make modifications easier for the owner. Furthermore, the project lead time, or the time that it will take you to finalize and finish this project will be much less, since we are consuming less steel. I think it's fine. Thank you. Anyway. In addition, if we use high-graded concrete with the high-graded steel of ES600, we will have a possible combination of very high quality products, and that could be also possible for concrete savings. Now, we will also be the developer will also have higher floor space area, and that is because we will be reducing the amount of steel we use in our vertical elements of our building, let's say. Now, moving on to the consultants. That's also a point that I forgot to mention. As shown in the previous example, this product promotes sustainability and improves construction environment. If I'm going to go back to the example before, if we want to build a 40-story tower, it will take 40 tons of carbon emissions that will be reduced from the transportation emissions, and this is equivalent to 20 loaded trucks traveling 20 kilometers each. Now, let me tell you how the consultant could benefit from this newly launched product. In high-rise buildings, at the lower floors, there is usually no space to pour the concrete. In using the ES600, you will be using less rebar in this foundation, which will allow you to pour the concrete effectively and efficiently. Furthermore, in viewing galleries such as aquariums, it will be more aesthetically pleasing to use the it will be more aesthetically pleasing in using the ES600, as we will be also reducing the vertical element of the structure. The contractors will also benefit, similar to the owner. They will benefit in a lower construction lead time for the project. They will also manage to save up to 18% of the logistics costs, as well as the storage laydown area in the construction site can be reduced by up to 18%. In addition, in using the ES600, since we will be using less material, it will reduce the site activities that are done in the site, which will also allow us to reduce the manpower by 18 to 24%, which can improve safety in the project. Now, moving on to the fabricator where the cut. Yeah, but it needs this. Now, finally, the fabricator can save up to 18%, just like the contractor with the logistics factor, and it will also they will also manage to reduce the storage space by up to 24%. And the reason why it is higher than the construction's savings in the storage space is due to the way they will be storing these rebars. Finally, combining all these direct benefits of the parties of using the ES600 with the indirect benefits, such as reduction of manpower and project lead time, it could result in an average gain of 18 to 28% of the steel cost. As you guys can see in the screen behind me, these are the certifications that were done this is by the Dubai Municipality, this is by the ADM, Abu Dhabi Municipality, the Al Ain Municipality, Al Dhafra Municipality, and Abu Dhabi Quality and Conformity Council certificate, as well as finally the Ajman Municipality. As you guys can see as well, we have the sample MTC, which showcases the mechanical and chemical properties of the product. If you guys want, allow me to give you a piece of advice. If you are ever in any doubt about the sample MTC of a product, you can scan the QR code that is shown on the bottom left of the screen, which will allow you to verify that product. Thank you.
Ladies and gentlemen, please join us for the 10 minutes coffee break, and we shall restart later on. Thank you. Dr. Tamer Al-Madawi from UAE University will present the second working paper in our workshop today, titled The Use of High-Strength Steel in Concrete Structures. Dr. Tamer.
Thank you very much. Good morning, everyone. Before I start my presentation, I would like to thank Emirates Steel, DED, and Abu Dhabi Municipality for organizing this event. We are very pleased and honored to be part of it. So as we are aware of, the recent research actually resulted in producing and commercializing high-strength steel, including ES600. So this actually required significant changes in ACI code provisions. So we had a project funded by Emirates Steel, and in this project we actually had specific objectives. These objectives are to review carefully the new changes in the ACI 19 and also identify differences between the old code 08 edition and the new code 19. In addition, we also had another objective to prepare value engineering design samples for conventional floor in a conventional building in order to compare steel quantities using two different steel types. One is ES600 and the other one is B500B. So our presentation, the team from UAE University included myself and Dr. Aman Muafi. So our presentation is divided into two parts. In the first part, I'm going to talk on the changes in ACI code 19, and also I'm going to compare the differences between the old code and the new code. And then in the second part, Dr. Aman will elaborate on outcomes of the value engineering design sample. So this is the agenda of my presentation. So in the beginning, I'm going to actually brief you about the documents we used in our project, including relevant ACI building codes, mainly, as I mentioned, 19 versus 08, and ICC evaluation report, as well as ASTM standards that's actually related to the high-strength steel, including actually ES that we used in our project. Then I'm going to share with you the overall organization of the 19 version versus 08, just to familiarize ourselves about the main differences in terms of the structure of the code. Then I'm going to present to you details related to tensile property requirements in the ACI code, the new one, including, because this is very important, including differences between 615 and 706. How ES is fitting here, it's actually defined by ICC as alternative to A615, and this will also be presented in this part of our presentation. Then I'm going to move to explain and share with you our findings regarding the permissible applications and prohibited applications, requirements and limitations for each type of steel. And this will include also at the end key changes implemented in the ACI 19 in order to accommodate the use of the high-strength steel in construction. Then at the end, I'm going to actually present some concluding remarks. So this is actually the old version of the code. It is outdated. It's ACI 318.08. What we need to focus on here is to emphasize that in this version, we had specifications for 3 different grades, 280, 420, and 520. This code actually, in particular applications, it allows the use of a yield strength up to 550 in specific applications under specific limitations, up to 550. For example, in shear, it does not allow to 550. It actually provides an upper limit of 420. But in confinement, in some applications, it allows up to 700 actually. But generally, the properties of the grades were actually 280, 420, and 520. 520, actually, each one of these stands for the yield strength. So as I mentioned, the upper limit is 520 in terms of grades, but because they allow it up to 550 in some particular applications, they mentioned and they were aware, if you implement 550, as you can see at the last bullet, there is a concern, or actually concerns related to ductility, serviceability, and confinement and development length. So they mentioned if you are going to use 550 in particular application, there is a risk. And they were aware that there is a need to update or change completely the design provisions in order to fit 550. So imagine if we use 600 or if we use even 700. So this certainly required the changes and modifications in the design code. So if we move on to ACI 19, generally we will see in a few minutes that it focused on design of members in specific chapters. So you will see shortly that member-based chapters are expanded, and this will give you opportunity, any designer, to find everything related to that member in that chapter. What else? It allows the use of higher steel grades, including 550 and including even, it's 690, but let's call it 700. Changes have been made also in the new code related to properties of the materials used in specific applications. So as I mentioned, we have 2 types. One is called A615 and the other one is A706. So the requirements of these 2 types have been updated in the ASTM standards and also in the ACI code. And this is very important. Changes in the design actually have been made in order to address concerns. If you use high strength steel, then probably you will get thinner sections, so deflection and serviceability would be a problem. So serviceability actually equations might not be applicable. Some changes also took place in terms of strength, deformability, and ductility. In general, if you have any concrete member you are designing at the moment, then they must comply with ACI 19 regardless of the steel type. So it's 08 is outdated, but if you are going to use high strength steel, so it is actually doesn't account for the concerns that address in the new code. So this is also something that's important to take into consideration. I invite you after the workshop to download 2 STM standards. One of them is for A615 and the other one is for A706. In the following slides, I'm going to brief you about the main differences very shortly. In terms of the new steel that produced by Emirates Steel, it's approved by ICC, and they have issued already evaluation report that has the requirements, limitations, and as we will see very shortly, they recommended to add properties of this type of steel in the ACI code in the coming edition, and this has been written obviously in the report. So as you can see here, it's allowed to be used as per the ICC. And in the second bullet, you will see that in this report, it is in the coming ACI edition, you will see as per this recommendation, unless it will be implemented in the STM. But they recommended to have a table specifying properties of grade 600 in the coming edition. So if you are planning to design a concrete element using ES600, then you have to use requirements and limitation in that report. This report is available online for free. And also in this report, you will find that the requirements and the limitations are compatible with requirements and limitations of the ACI 19. So you need, if you are designing any concrete member in any concrete structure, you would need to have both in hand, and you have to follow the requirements and the limitation of both. One of them is 19th version of the ACI code, and the other one is called Evaluation Report of ICC. Moving on to the main difference between ACI 19 versus ACI 08. This actually figure shows the structure of each report. So ACI 08 on the left side, it consists of 22 chapters, as you can see. We have 2 introductory chapters, and then we have 5 chapters on construction and materials, 1 chapter on strength and serviceability, and then we have 3, they call it behavior-based chapters, and only 3 member-based chapters. This member-based chapter, most probably they are chapter 13, for example, two-way slab. This is specifically for two-way slab. Walls is specifically for walls, and then footings is specifically for footings. So we have only 3 member-based chapters, and then we have 7 chapters with different topics, and then we have 6 appendices. If we move on to ACI 19, we have 27, not 22. So the number of chapters increased because some of the appendices in 08 became chapters in 19. What else? We have 3 introductory chapters. We have 3 chapters on structure system, loads, structure analysis. And the most important part, we have 7 member-based chapters. So this, I think, will start from chapter number 7. So we have 1 chapter completely assigned for one-way slabs. You will find everything in that chapter related to one-way slab. And then if you move on, you will find two-way slabs, beams, columns, walls, etc. So if you count, you will find 7 member-based chapters, and then 1 chapter on plain concrete, 3 chapters on connections, 1 chapter on earthquake-resistant structures. This is a very comprehensive chapter, and it is very beneficial as well. And then we have 5 chapters that actually can fit. It has, I mean, these 5 chapters, they have tools that could be actually applicable to multiple types of members. And then 2 chapters on construction documents, evaluation of existing structures, and then it concludes with only 3 appendices. Typically, when they have draft chapters, they provide it in appendix, and then when it develops more and becomes mature, then they put it as a chapter. And this is actually explains the reason why we have only 6 appendices in 08, and we have only 3 in 19. As I mentioned, some of the appendices actually were upgraded and became mature and became chapters in 19. Going to tensile property requirements, the table at the top provides data related to ASTM 615, and the table at the bottom provides data related to ASTM 706. Why I'm presenting this here? Because in the coming slide, based on the ACI 19, we have specific applications for 706, and in these kinds of applications, 615 is not cannot be used. So you need just to be aware of the main differences. So in both tables, we have, of course, a specified minimum yield strength, a specified minimum ultimate strength, a specified ratio of the actual tensile to yielding, and elongation. If you compare, you will find that, for example, the ratio of the actual strength in A615 is 1.1. So if you actually satisfy these requirements, it's okay. In 706, no. In order to be identified as 706, and this will allow you to use it in other applications, it has to be 1.25, for example, in grade 420. And then in grade 550 is 125. 690 as per SI 1.17. So these are the main, the message I need to deliver here. 615 has specific properties different from 706. How ES is fitting here? So as per the ICC report, it is actually defined as uncoated deformed reinforcing bars, and they are used as alternative to ASTM 615. So ES600 is considered by ICC as 615 type, and of course is for reinforcing concrete structure. Properties, these are the minimum properties. So since it's called ES600, so the yield strength is expected is to be 600 at least. In terms of tensile strength, it should be at least 690. Elongation, it should be at least 7%, and the ratio of the ultimate strength to the yield strength should be at least 1.1. Just to give you an idea about how this is fitting into A615, look at the last two numbers here. So elongation 7%, and the ratio of the ultimate strength to yield strength is 1.1. If I go backward, in the table at the top, you will find elongation is 1.1 for 615. So this actually confirms that ES600 fits ACI 19 for steel 615. In terms of the elongation, if you can see here, for example, of course, the elongation in the ASTM standard is dependent on the bar diameter. So if you would like to have more information about the exact required elongation for each bar diameter, you go download STM. Here I'm providing ranges based on STM, and there is a note that the exact value is provided in STM standard. So for example, 550 here, the elongation required is, we are talking about 7%, 6 to 7% based on the diameter. If I go again to ES600, you will find also the ratio is, the elongation is 7%. So this is to confirm these properties which are existing in the evaluation report of the ICC match properties of A615 in the STM and also in the ACI 19. This table, actually the information in this table extracted from ACI 19. So I'm not going to go into details here. I invite you to visit the ACI website. Of course, if you have a copy of the code, then you need to go and go through this table to get more details. But the message I need to deliver here, which is actually in red boxes. For example, as you can see, 706 for a special seismic system, including special moment frames, special structural walls, then you must use 706. This is issue that you need to take care of. What else? For example, of course, this is if you are using longitudinal bars or anchor reinforcement, then you have to use 706 in a special seismic systems. In the last, actually, in the third row, you will find other, and it seems to be open up to 690 if it's non-spatial. However, there is another provision in the code that says you cannot use more than 550, for example, if you are estimating the capacity of a column under pure axial load. So this actually note, I have it here also on red, the first one on the right, the third one on the right side. What else? I'm also highlighting note number 5, which is actually extracted from the ACI 19 code. It says that longitudinal reinforcement with F yield more than 550 is not permitted for intermediate frames and ordinary frames resisting earthquakes. This is very important to take into consideration. If these frames are used to resist earthquake loading, then F yield more than 550 is not allowed if it's 615. If it's 615. What else? Note number 9. I'm also highlighting note number 9 because it indicates that grade 500 or higher are not permitted for stirrups. So the upper limit for the yielding strength is 420. And in the current version of the ACI 19, they said you cannot upgrade or use a higher value of F yield. So they emphasize that 550 is not allowed in shear reinforcement in particular. Why I'm emphasizing this here? Because they allow it actually for, as far as I remember, welded wire reinforcement. But for deformed bars, it's not allowed because it's something related to serviceability. When you go to, and this is something also promising for ES600, when you go to the ICC report, you will find the properties allowed to be implemented in design for ES600. If you are using this bar as a longitudinal reinforcement, then you have some limitations, some maximum yield value to be used, compression reinforcement the same. Here for transverse shear, for example, currently compatible with ACI 19, the limit is 420. However, in the same report, they provided a note that in beams and walls, even in shear, you can upgrade it to 550. You can use this ES600 with F yield 550 under a condition that if appearance and serviceability due to shear cracking are not critical design consideration, although it's not mentioned in ACI 19. So the note I'm actually surrounding it with a box here is very promising because similar to what I mentioned in terms of recommending adding a table for properties of the ES in the ACI code, they actually recommended in the coming edition of the ACI code to allow and write a statement that you can use F yield up to 550 even in shear under this condition. It's a recommendation from the ICC, and it is very likely to be implemented in future edition, but until it comes, we have to wait, and then later we can verify. So as I mentioned, you can use ES600 as longitudinal reinforcement, tension, compression, shear. You need to observe the elements you are using the bar and the corresponding yield strengths you need to implement. Do we have a specific restriction that you cannot use from the beginning? Yes, we do. So the report I told you at the beginning, which is available online by ICC, which is also compatible with ACI 19, we summarized these limitations in that table. So briefly, without going into details, because I strongly recommend you to download the report and comply with it in your design. But for example, seismic force resisting system in SDC DEF, not allowed. A special moment frame, not allowed. A special structural wall boundary or coupling as part of a special structural walls, not allowed. So, and these are typically used in regions of high earthquake demands. So, headed deformed bars in tension. So these actually you have to take this into consideration during designing a concrete element reinforced with ES600. All right, so now we understand properties. We know when we can apply the steel bar and when we cannot. How to use the new ACI code? This is very challenging, by the way. So we summarized the key changes of the ACI into 5 categories. Number 1 is related to changes related to properties and applications, and this has been covered in my presentation in the previous slides. So issues or changes related to 706, 615, elongation, actual ratio between the strengths, the ultimate strengths to yield strengths. So these changes actually have been covered. What else we need to know? We need to know changes that are related to serviceability, strength, ductility, anchorage, confinement, etc. So I'm going to take you actually till the end of my presentation to elaborate more on each item of these displayed on the screen right now. So item number 1 is gone or has been covered. Let's go to serviceability. What are the changes happened in ACI 19 to accommodate? Why these changes happened? These changes happened actually because the new ACI code allows use high strength grades. If you use high strength grades using the old design provisions, then it might not be conservative. So it required a change. If you don't allow use of the high strength steel, so maybe the modification could have been minor. But since you, for the first time, you allowed use 550 and up to 690, then existing code equations related to serviceability, strength, ductility must be modified, and I'm going to briefly explain to you why it should be modified. So let's go now to box number 2, which actually related to key changes of serviceability. So serviceability, we have in this category 2 items to cover. Item number 1, it changes in the minimum thickness of two-way slabs unless deflection requirements are satisfied. We are aware that if you assume thickness of a slab as per the table, then typically, by the way, the code says if you have high live load, then you have to check deflection. But typically, detailed calculation of the deflection might be waived if you abide by the minimum thickness. So you can find in this table the first 2 rows actually for 280 and 420, they are the same, like 0.8. But for the first time, we have minimum thickness is specified for steel grade 550. It was not existing in previous code. What you need to keep in mind, which is also very important, if you need to fully utilize high strength steels in general, including of course ES600, then in many cases you might select a thickness of a slab that's actually lower than the ones provided in the table, and then you check deflection by hand calculation or by software in order to fully utilize the high strength steel. If you do that, the code says that's fine, you go and you make a check deflection. However, as a further protection, when you make a check for the deflection, the rupture strength used in the calculation should be reduced in order to get a reasonable deflection that's expected if you use high strength steel. However, the reason is if you use high strength steel, then we expect low amount of reinforcement. Low amount of reinforcement, so the transformant moment of inertia will be low. So the deflection might be higher. And this actually required a change even in the effective moment of inertia. They found the old equation for the effective moment of inertia does not provide accurate estimates for the deflection if the concrete member in general has low reinforcement ratio. So this is actually linked to use of high strength steel. So if you use high strength steel, most probably you will get low steel ratio. If you get low steel ratio, then the deflection estimated by the old code very likely will not be accurate. That's what they said. So on the left side, you will see the equation for the effective moment of inertia used in the calculation based on ACI 08. This equation is gone, is not valid anymore. So if you, regardless of the type of the steel, by the way, so in ACI 19, for the effective moment of inertia, they don't actually distinguish between a steel grade. Regardless of the steel grade, you have to use the new equation, and this new equation actually, based on some rough calculations, it will give you a lower, most probably at low steel ratio, it will give you most probably a lower effective moment of inertia, and then accordingly the deflection calculated based on the 19 code will be higher than the deflection calculated based on 08. So 08 is outdated and it might not actually provide you a conservative design adequate satisfying the requirements. So now we are done with properties, application of reinforcing bars, and we are done with changes in serviceability requirements. And all of these were triggered in order to address the concerns that's mainly caused by accommodating high strength steel, including 600 and 690 and 550. What else? Let's go to strength. In strength, we have 1, 2, 3, 4. In strength, we have 4 items. Number 1 has been explained already. So in terms of strength, you cannot use the yield strength in all applications. And this is valid for ES600 or ES690 or ES550. So as I told you, depending on the application. For example, very obvious example for the shear, regardless of the type of steel. So even in the shear in the ACI 19, for other types different from ES600, then in many cases the yield strength is limited to 420, for example. So imposing an upper limit, as I mentioned, another example is the concrete column under pure axial load. You cannot use more than 550 even if you have a steel 690. But this only in that condition. So imposing upper limits in specific applications has been covered. What else? They provided some limits, minimum concrete strengths to be used in practical application, or again to accommodate high strengths. So for example, and this example actually is for special moment frames and special structure walls. Based on the steel grade, you can see, for example, special structure walls with 690 grade, you cannot use concrete strengths less than 35 megapascal. This is just an example to give you an idea about changes made in the ACI 19 that did not exist in 08. What else in terms of strength? It changes in the method of calculating the strength reduction factor. This is also crucial. We are fully aware that design philosophy for bending, for shear, for axial, design strength must be more than the quad strength. And the design strength can be obtained by multiplying a strength reduction factor, phi, times the nominal strength. Sn here could be moment, Mn, it could be shear, Vn, it could be axial load, Pn. If you multiply the nominal strength times phi, you get the design strength and this must be at least equal to the ultimate strength or higher. Ultimate strength, of course, it comes from a load factor. So you have a dead and live, so one of the load combination is to magnify load, dead load by 1.2 and the live by 1.6, for example. So you need to satisfy this requirement. So how can we get the value of phi? Because this actually affects the strength directly. So the approach they used in 08 is different. How it's different? In 19, different from 08. How different? Take a look at this basic strain compatibility example. We all had this in our undergrad. This is actually the strain profile along L section depth. From this strain profile, you can get the strain at the tension steel. We call it epsilon T. What we are going to do with it? So this diagram on the left side represents a relationship between phi and the strain at the extreme layer of steel reinforcement. The first limit is actually if the section is going to be compression controlled, which is actually crushing without yielding. So obviously the strain in the steel will not exceed the yield because it's compression control. So compression control means the steel has not yielded. So if you have any section with steel reinforcement strain less than the yielding strain, as you can see on the first limit here, this is classified as compression controlled, and basically it's a brittle mode of failure. How to define ductile section? So in order the section to be or tension controlled, how to define a tension controlled section, which actually will provide you the most sufficient ductility actually. This can be achieved if the strain in the steel exceeded epsilon yield plus 003, which is actually the third zone on the extreme right side. I'm not sure if this mouse will work or not. Yes, maybe this one. So this is actually the tension controlled zone, and this one is the compression controlled zone, and this one is in transition. What does it mean in transition? So if it's compression control, the strain in the steel must be less than the yielding strain. If it's tension control, then the strain in the steel must be more than this limit. And then if the strain in the steel is in between, the ACI classifies the section as section in transition. So what is the difference between this and what was in 08? In 08, this actually was constant. This was not linked to the steel grade. Each steel grade, how can we get actually epsilon Ty here? So epsilon Ty can be obtained directly by just dividing F yield over ES. So the message I need to deliver here, if you change the yield strength, then you get different value of epsilon Ty. If you get different value of epsilon Ty, then the limit that will actually distinguish between tension control and other will be dependent on the steel grade. But in ACI 08 it was not. It was constant. So you cannot actually use the old provision because this will certainly affect your design, and we have an example that will be presented in the coming presentation. So here, this actually is not valid anymore. You cannot use 0.05 in order to identify a tension controlled section in ACI 19. As you can see here, because this item is related to strength reduction factor. Strength reduction factor on the y-axis is related to the strain in the steel. So if the values on the x-axis is different from the old code, then the phi values also will be different. So phi values for calculated based on ACI 19, especially in transition zone, will be different from their counterpart calculated from 08. What else? This is elaboration more on a previous slide, so it provides the same information. Just I need here to highlight that the tension controlled, if you have a tension controlled section, then phi equal to 0.9. If it's a pure compression controlled section, then it's 0.65 or 0.75 based on the confinement. If it's in between, there it's interpolation. If the limit for the tension controlled is it changed because it's now dependent on the steel grade, then the phi value will also be changing, particularly in the transition zone. And of course, the limit to identify tension control will also be changed. What else we have here? The last item in the changes that are related to strength, a change in the expression used to calculate the nominal shear force carried out by the concrete. So the value of VC was actually has been calculated using the ACI 08. The equations used previously to calculate VC exist on the left side. We are talking here about one-way shear, because two-way shear is another change. So on the left side, these equations actually have been cancelled from the new code. So the expressions used to calculate VC have been changed, and they are currently dependent on the section size. So they actually changed the equations. They provided some equations. If you have shear reinforcement less than the minimum, you have expression. If you have the shear reinforcement more than the minimum, you have other expressions. And in these expressions, they introduced something called section size. So this was not actually existing in ACI 08. And the rationale behind it is also to account for possible changes in the shear strength if you use higher section size or lower section size, and all of these might be affected also by the steel grade. On another note, on the right side, it is actually also important to highlight that, as per the code, it is allowed to neglect a size effect if you are designing isolated or combined footing, and this actually provision is stated in section 13.2.6.2 in the ACI 19. Now, if we go to two-way shear, we have also changes. So the set of equations we were using in the past are not valid anymore. So you have to use a new set of equations, and these equations actually, as I mentioned, they have the section size. We have other actually parameters that affected the new equations, but the new parameter that also introduced is the section size. But regardless of the section size, we have also, I think, some differences in the equations themselves. The last item in the strength is still related to two-way shear. So here, in this table, you will find again for punching shear, because previous slides were for one-way shear. Now for punching shear, the equations have been changed as well, and the section size is also part of the story in these equations. And they even classified VC, this is the shear stress, by the way, not the shear force. So they classified equations if you have shear reinforcement for punching, and different equations if you don't have shear reinforcement for punching. This actually was not existing in 08. So now we are done with properties of the steel reinforcing bars, serviceability, and strength. Let's move on to ductility. How the use of higher steel grades would affect ductility, and what are the changes made in the new code in order to accommodate the use of high strength steel. So luckily, the first two items actually, the first item only is also covered, because ductility is also related to tension controlled versus compression controlled versus transition. So this has already been covered in some of my slides, but that was related to phi. So the same figure, the phi value will be changed, and also classifications of tension controlled versus compression controlled, which would affect ductility, has been also been changed. So this is a concern that you need to take into consideration. It is very important also to highlight the following. In ACI 08, it was not a must for flexure members to be tension controlled, because tension controlled was classified if you exceed 0.005. But in previous code, they allowed to be even 0.004, which is on the left side here. So this is gone now. In the ACI 19, it is a must for one-way slab, for two-way slab, and for beams to be tension controlled. You cannot go in the transition zone. They must be tension controlled, and this will affect certainly design. This is it changes in the limit, the ductility. Actually, we have one more item here in the ductility that's related to the minimum area of steel. Why I put here this in the ductility? Because if you have area of steel less than AS minimum, then brittle failure might happen at the onset of cracking, then failure might happen immediately. So you have to provide area of steel more than the minimum. And also it's related to distribution of the steel and the crack widths. But, so in ACI 08, as you can see at the equation at the bottom, the minimum steel ratio was function of F yield. So if you keep increasing F yield, what would happen is you keep decreasing the amount of the minimum reinforcement. So if you use 690, for example, you end up with a very little AS minimum that actually might result in a non-conservative design. For that reason, this has been changed, and now the minimum area of steel for one-way slab and two-way slab, they became fixed, not dependent on F yield. You must provide a minimum of 0.018 of area gross. Even if you use high strength steel, this does not allow you to reduce the value of ES minimum. This is also an important aspect. Regarding ductility as well, so we mentioned that in a previous slide. In one-way slab, it's 0.0018 area gross. In two-way slab, it's 0.0018 area gross also. But in two-way slab, they have introduced additional AS minimum in a specific case, and this has been introduced in the first time in ACI 19. What is this case? So they mentioned, by the way, I invite you to download the errata of the ACI 19 because they have many typos. For example, in this equation, they have a typo. So if you have the shear stress from bunching exceeding this limit, so 0.0018 is not sufficient. You have to add additional, you have actually to use another equation for AS minimum. It might give you additional steel as a minimum value, and the rationale behind it is to actually mitigate a flexure-driven punching failure. What happens is, if you are using high strength steel, so it's very likely you will get low amount of flexure reinforcement. So if you look at the figure on the right side, if we have low amount of flexure reinforcement, so when yielding happens in the flexure reinforcement, this will result in a rotation, increase the crack widths, so a punching failure might happen earlier. So we need to prevent early yielding of the flexure reinforcement in order to prevent early punching mode of failure. For that reason, the minimum area of steel might be actually higher than 0.018. Still, minimum reinforcement actually provided by the code, the set of equations are the same. For ACI 9, for beams, they are the same for ACI 19 versus 08, if we are talking about beam. The addition is, as you can see on the left side, the equations are dependent on a field. So same scenario. If you keep increasing the yield strength of the steel, then you end up with a very little minimum amount of steel. And this might be unsafe. For that reason, they provided an upper limit for a field. So if you use high strength steel reinforcing bars, then the minimum area of steel that will be used will satisfy the serviceability, strength, and ductility requirements. The last item in my presentation before I conclude is related to changes for anchorage, confinement, and other issues. This is also very important because the development length equations have been changed significantly in ACI 19. So I'm not going to go into details here. What I need to highlight here, in addition to the changes made in the equation itself, they introduced a new, I'm not sure if we have a circle here, yes. They introduced a new factor that's dependent on the steel grade. So the equation itself has been changed, and we have a parameter that's dependent on the steel grade. And as you can see on the right side, for grade 280 or 420, the factor is 1, 550, 1.15. So for higher steel grade, we expect more development length. For 690 is 1.3. By that time, they didn't have data about ES600, but interestingly, in the ES report, they accounted for that. So they mentioned if you are designing a concrete member with ES600, you take the factor as 1.3. So when you are designing a concrete member, you have to have ACI and you have to have the report, because this is a very practical example. If you look for the value for the grade factor here for 600, you will not find it. But this factor is specified in the ICC report. Again, the development length I presented in the previous slide was for tension reinforcement. Straight, actually, tension reinforcement, straight bars. In many cases, you need hook at the end. If you have hook at the end, then the development length equation is changed. So here, this equation also is different from the one that actually existing in 08, but it's valid for any F yield because F yield is a parameter in the equation. This is also another issue that need to be taken into consideration related to confinement reinforcement. So as per the ACI 19, they mentioned that if you are using steel with a yield strength more than or equal to 550, then you have to provide confinement reinforcement along development length of the steel reinforcing bars. And this actually is specified in chapter number 25, and it is actually specified in the chapter related to beams and also chapter related to columns. The last slide before I conclude, I just would like to give you a message that chapter number 18, that's related to earthquake resistant design, witnessed significant changes. Many of them are related to different steel grades, and there are many others changes that's also might not be related directly to steel grades. So I invite you to visit the chapter and also extracted some highlights here for intermediate moment frame, for special moment frame, for special structural walls, and the sentences are in red, or the actual parts of the sentence in red that shows some specifications, particularly if you change the steel grade. So on the first column, you have some specifications based on a steel grade 420 or 550. In the second column, again, you will find the new requirement, and it's dependent on 420 or 550, and this is actually everywhere. Now, in the special structure walls, again, they have significant revisions that's related to development lengths, splices of reinforcement, and at the end, they have also changes to accommodate different steel grades, including 420, 550, and 690. And also, as I mentioned, ICC has recommended implementation of ES600 in the coming ACI edition. So in conclusion, so now just to make sure that we wrapped everything, so the 5 categories have been covered. So in conclusion, we need to make sure that ACI 08 should not be used for design of concrete members. It makes sense. It's as long as you have new codes. So by default, old codes are outdated. But here the issue is important because if you are using high strength steel 550 or higher, then the old code doesn't account for the high strength steel at all. So the issue is more critical here. So ACI 08 shall not be used for design of concrete members, especially grade 550 or higher, of course, including ES600. Why? The reason is design provisions of 08 don't address the concerns that's actually related by the use or linked to the use of high strength steel, as I mentioned, which includes serviceability problems, strength problems, detailing problems. All the equations in 08, or the majority of the equations, don't account for issues that might happen if you use high strength steel. For that reason, you have to use ACI 19. Examples in terms of deflection, as I told you, effective moment of inertia equation has been changed. So if you use 08, it might actually give you a higher moment of inertia than the one that actually used in 19, and this will actually in 08, if you have higher moment of inertia, then you underestimated deflection. In terms of strength, if you don't account for the section size in sheet, for example, if you don't account for the phi value in the transition zone, so 08 might give you actually unconservative results compared with, it might overestimate the design capacity compared with the capacity calculated based on the ACI 19. In terms of the ACI 19, so just to wrap up, this is to emphasize that high strength steel, including ES600, is allowed by ACI 19, but this required the changes in the design provisions. And ES600 in particular is part of a 615 family. It's allowed by ICC, and they recommended to add properties of the steel bars in the coming edition of the ACI, as well as emphasizing that it can be used as long as you use ACI 19 in your design. And this is also to emphasize that concrete members reinforced with high strength steel, including ES600, must be designed using ACI 19 and the ICC report that has been issued recently. So before I conclude, I would like to acknowledge the support provided by Emirates Steel, and I would like to thank Emirates Steel one more time for giving us the opportunity to contribute to the community and the society. We encourage you, actually, as I mentioned at the beginning, we encourage you to download standards, ASTM standards, the ICC report, ACI, and even in the ACI, I encourage you also to keep an eye on the errata. The code is new, and they have some editorial errors, and they corrected these errors in the errata frequently. So you need to apply your judgment and download the errata because it might affect your design.
So I think this would conclude my presentation. Thank you very much for your time. And I think maybe the questions will be later, right? Okay. Thank you. I would like to remove this. Okay.
نرجو من الجميع مسح الباركود الظاهر على الشاشة للمشاركة في جلسة الأسئلة والأجوبة التي ستكون بعد عرض الدكتور أمان.
Please scan the barcode showing on the screen to participate in the Q&A session, which will be after Dr. Aman's presentation. And due to time limitations, we will skip the break and we will move directly to Dr. Aman.
الأخوة والأخوات، فقرتنا التالية ستكون مع الدكتور أمان موافي من جامعة الإمارات ليقدم لنا ورقة عمل تحت عنوان نموذج التصميم الهندسي، فليتفضل الدكتور مشكورا.
Our next segment will be with Dr. Aman Muwafi from UAE University, who will present a paper entitled The Engineering Design Model.
DED for this opportunity. This study and this project is a project supported by Emirates Steel. And the main objective from this project was to review the design codes, summarize the limitations and the applicability of using high-strength steel, and then to provide value engineering design samples. So what I'm going to present here is the value engineering design sample in the first part of the presentation presented by Dr. Tamer, because this work was done by a team from UAE University, Dr. Tamer and myself. So Dr. Tamer mainly covered in detail he reviewed the code, covered the limitations and applicability of high-strength steel, changes in the design codes, compared between ACI 08 and ACI 19. Now, we wanted here to apply this to a real-life design sample. So this is what I'm going to present in the second part of this in our presentation. So the contents and the agenda of my presentation will include the following. First of all, I'm going to show you or cover an overview about the study and the design sample. We will cover it today. And then I will talk a little bit about the selected building. What is the building we selected for this value engineering design sample? The conventional floor slab we selected, and the design criteria assumptions related to this selected case study. And then I will cover the first design sample. We will cover it today, which mainly we focused in this first design sample on comparisons between steel ES600 and B500B. To compare between the two steel grades, we used ACI 19. Why? Because ACI 19 allows to use high-strength steel, of course. So we covered in this first design sample four types, four-member structural members, mainly one-way slab, continuous one-way slab, continuous beam, a column, and a shear wall. We extended this design sample to compare between the design of these four structural members. Mainly, if you design these structural members using the old code, ACI 08, and then what if you designed the same structural members using the new code ACI 19? And then I will summarize and provide you with some comparisons between the results obtained from these two design samples. And finally, I will summarize and give brief information about the limitations of our study, because any study, of course, you will have some limitations, and finally, concluding remarks. I'm not gonna go through the requirements, limitations of the code again, because this is covered in detail by Dr. Tamer. But here I will talk a little bit about two very important tables. One of them is from the ACI 19. This table is crucial for any designer. Whenever you design a structure using any type of steel, you need to have this table in mind. There is also footnote below this table. I just included here a couple of important requirements from the code. these two requirements are very important. Dr. Tamer covered this in detail, but mainly you are not, if a field is above 550, so the longitudinal reinforcement is not permitted in ordinary and intermediate moment resisting frames. And also, we cannot exceed 550, a field 550, if the structural member is mainly under pure axial compression. So these two requirements and limitations are included also in addition to the F-yield values shown in this table, table 20224 in the ACI code. There is another table also in the evaluation report, the ICC, the International Code Council report. This table also, you should have it with you because it complements the ACI code as Dr. Tamer explained in his presentation. ES600 is not available in the ACI 19. So the evaluation report here mainly focuses on ES600 and provides here recommendations. What if you are designing one-way slab? What if you are designing column? What is the F-yield values you need to use for each of these structural members? So depending on the applications, the structure you are designing, you need to take the F-yield values from this table, and you need to have the ACI 19 table with the evaluation, ICC evaluation report table, table number 5. In addition to this table, there are some additional requirements also. I listed here a couple of important requirements. One of them is that ES600 cannot be used as longitudinal reinforcement in special moment resisting frames, boundary elements, and coupling beams of special structural walls. We know that in many areas in the UAE, we don't need to use special structural members, but this is just for your info. Also, the ICC evaluation report doesn't recommend or doesn't permit using ES600 in structures assigned to seismic design category D and above. If you wish to use ES600, you can use it in slabs, foundation, structural components, but these structural components should not resist seismic loads. So this is the second important table. Why I talked about this? Because we will use these tables and the information in these tables in our value engineering design sample. Regarding the ACI 08, again, this is a summary of the ACI 08, which is adopted by Abu Dhabi International Building Code. So mainly, F-yield should not exceed 420 with some exceptions, and also typically in other design calculations, you cannot exceed 550. So if you design a structure and use high strength steel, of course you cannot use ACI 08, you have to use ACI 19. So I'm emphasizing this because in our second design sample, we will compare between ACI and ACI 19 and ACI 08. So we have some limitations here regarding the ACI 08. So mainly it cannot be used to design structure if you use high strength steel. So our value engineering design sample, as I said, first design sample will illustrate the comparison between ES600 and B500B. And for this, we will use the new code ACI 19. For the second design sample, we will compare between the two codes. Since we will compare between the old code and the new code, we cannot use high strength steel. Okay, so for the second design sample, we used only B500B. So one of the limitations that I'd like to talk about here is the some limitations in some software currently used in design offices. The software we used here has some small limitations about the F field. If you use it in design of columns, it has an upper limit on the F field of 550. So this was a small limitations, but I will cover this during my presentation. What is the implications of this limit imposed by the software? So for the building, we selected for this design sample, this is the building. We selected a structure, a typical structure consists of ground story and 7 typical stories, in total 8 stories. We assumed that the structure is located in the city of Abu Dhabi. The structure consists of 8 stories, as I said. The ground story is 4 meters high, and the height of other stories is 3 meters. So in total, the total height of the structure is 25 meters. The layout of the structure is shown here. This is the layout of a conventional flooring system. The UAE team, me and Dr. Tamer, we went through several changes of this layout. Why? Because we wanted to select a layout for structure that provides later meaningful results. So we made several changes regarding the distances between columns, dimensions of structural members, because if you select a structure that provides bending moment, low level of bending moment, for example, so you may end up with small differences between steel grades. So we made several changes here to come up with meaningful results, but we highlighted in our report that it is the responsibility, of course, of the designer and the reader of our report and our study to interpret the results. So we, as I will explain later, we came up with some results and expected saving in steel if you use steel ES600. But of course, this depends on your structure and how you use this material, the material. The ES600 is a new material. So how can you utilize this material in your project, okay? So this is a very important piece of information I'd like to emphasize here. So the layout here, the total length of the building is 42 meters, the width is 20 meters, and arrangements of columns and shear walls are shown here. I will talk in the next slide about the structural system, selected structural system for this building. So mainly we selected here a building frame system for this structure. The definition of a building frame system according to the code ASC 7, the building frame system consists of shear walls resisting lateral forces, seismic forces, and a space frame that mainly resists gravity loads. So this is the main definition of the building frame system. We assume that the structure is an office building, so the occupancy and risk degree is 2. Based on the calculating the seismic design category, as you know, the seismic design category depends on several factors: seismicity, soil type, and the risk or occupancy category. So the seismic design category here is seismic design category C. According to the code ESC7, no limits is placed on the height of the structure if you are in seismic design category C, no limit on the selected structure system, building frame system. The flooring system here is assumed to support non-structural elements that are not likely to be damaged by large deflection. The shear walls selected to resist lateral loads, we assume that the shear walls are ordinary reinforced concrete shear walls. Mainly, we provided shear walls in the north-south direction and east-west direction. As you see here, we have 4 walls resisting lateral loads in the y direction, north-south direction, and we have 2 shear walls resisting the lateral loads in the east-west direction. Material properties assumed here, we considered F prime C 35 megapascal. Based on the F prime C, the calculated models of elasticity based on the code expression, of course, ACI 19. We are using here ACI 19. So this is the modulus of elasticity, modulus of rupture. The considered yield strength, and this is something I'd like to emphasize on. The considered yield strength of ES600 is, of course, 600 megapascal. For B500B, we considered here the actual yield strength of the steel. So we considered here for B500B, F yield equal to 500 megapascal, okay? I know that for B500B, in design offices, you use 460, but we wanted here to use the actual yield strength of steel because this steel has an actual strength of 500 megapascal. The gravity loads considered for this building, dead load and live load. Dead load is the self-weight, and also superimposed dead load includes floor covering and also partitions, etc. Live load considered for the building is 3 kilonewton per meter square, and it's 1 kilonewton per meter square for the roof, which is assumed unoccupied. So we started with developing a mathematical model for the building. This is the model for the building following the recommendations of ESC7 and ECI 19. All requirements were accounted for here. Seismic and wind loads were calculated based on ESC7 and Abu Dhabi International Building Code. So according to the ESC7 and Abu Dhabi International Building Code, we use the equivalent lateral force procedure and the analytical procedure to calculate earthquake load and wind load for this building. Seismic forces were applied in the 2 directions separately as permitted by ESC7 for regular structures in seismic design category C. Okay, so here the results from the 3D model we developed. Of course, why we developed the 3D model for the structure. Always we prefer to calculate loads using the software as it is usually done by any engineer in a design office. We prefer also to calculate loads using hand calculations. So we usually calculate the loads using hand calculation and software and compare between them because anyone can do mistakes, so you can see and confirm your calculations. So based on the calculating loads from the software and also based on hand calculations, the base shear here, seismic design base shear is 3,595 kilonewton. This is for the whole building in the two directions, of course. Seismic loads will not change because the structural system is the same in the two orthogonal directions. Wind loads, this is the maximum wind load, 1,235. Of course, the building has different dimensions in the two directions, so maximum wind load will be in the y direction, of course, because the exposed area is larger in the y direction. So the maximum wind load here is the wind load in the y direction, and as you see here, the seismic load, of course, governs the design, as it is the case in many structures in the UAE. Okay. The story, I'm sorry for the this text that is written on the some figures, but generally we check the drift of the building to make sure that the drift is lower than the allowable drift by the code for the design level earthquakes. So the drift for the building in the two directions were much lower than the code limit for risk category 2, which is 2%. So the drift was lower, much lower than the code limit. So now I'm going to present the first design sample, which presents comparison between the two steel types. What are the differences? What are the benefits when you move from B500B to ES600? And here we are using, of course, the ACI 19. So we started here the design of one-way, 5-bay one-way slab. So this is a strip. This is the layout of the building, and this is a strip. We considered here 1 meter strip for the one-way slab. The slab length in the short direction, as you see here, is 4 meters. The supporting beams, the slab is supported on beams with large cross sections. Why? Because the span of the beam is 10.5 meters, so the cross section of the beam is large, 0.4 times 0.72 meter. Considered this slab resists gravity loads only. Why? Because based on my based on the selected structural system, the beams and the slabs and the columns resist gravity loads only. So the load combinations considered for the design of the slab is the typical load combination under gravity loads, 1.2 dead, 1.2 dead plus 1.6 live. According to the ACI 19, the minimum thickness for the one-way slab is going to be calculated using this expression, the expression shown here. And the expression depends on the F yield. So for ES600, you need thickness of 210 millimeters. This is the minimum thickness for the one-way slab. For B500B, you need thickness of 186 millimeter. We decided here to select lower thickness for the slab. Why? We violated here the code limit, and we selected thickness for the slab equal to 150 millimeter. The reason for this is that we wanted, of course, to select unified thickness for the slab. Second reason was that we need to stress the slab a little bit to get some differences between the two types of steel. The third reason is that the slab is a one-way slab with a span 4 meters, and it is supported on large beams with large cross sections. So the width of the beam is 400 millimeters. So imagine you have a one-way slab supported on a beam with width 400 meters, and the depth of the beam is large, of course. So we believed that the slab will be safe, but of course, since you violate the code limit, you need to check the instantaneous, of course, and time-dependent deflection, and this should be done, of course, using the ACI 19, and this is what we did it. We checked the deflection of the slab using the new expression provided in the code. It's a detailed calculations, and we did these calculations manually, hand calculations, and we confirmed that the deflection of the slab is safe. So here, these are some of the results. This is the mathematical model of the slab. As you see here, the slab is 5 bays, and we considered strip here in the slab in the short directions. This is the shear force shown here and bending moment. Ultimate shear force, of course, and ultimate bending moment. And regarding the shear in the slabs, the one-way shear, 5VC was larger than V ultimate, so no need for minimum shear reinforcement in the one-way slab. For the bending moment of the slab, the figure on the right-hand side shows the moment capacity and considered critical sections. We considered certain critical sections in the slab to calculate the reinforcement using the 2 steel grades and compare between them. So summary of the design results, flexural design of the slab. We said for the shear, no need for shear reinforcement. Here, the top table shows the steel for 4 sections, 4 critical sections. When you design the sections using ES600, the next table shows the steel needed if you design using B500B. If you compare between the last column, rebars needed, you will see that for section number 1, we got the same number of bars, 5 bars, number 10. But we have here a note, these double asterisks show, and the note here written at the footnote here shows that for B5, for ES600, actually the area steel required 291 was less than the area steel required for B500B. But because there are some requirements in the ACI 19 regarding maximum allowable spacing between bars, so we couldn't use fewer number of bars. So we had to use the same bars, number of bars used for B500B. So it is not only the moment and the required area steel and provided area steel. You may have some requirements in the code that increase the number of bars. But we highlighted in our conclusion later that you may overcome this issue and achieve higher saving if you change the bar diameter. So here, if you have another bar diameter, number 8, for example, you may use, replace the area steel with lower bar diameter, so you end up with higher saving, of course. But we didn't change here because we wanted just to unify the bar diameter, so we kept section number 1 like this. For section number 2, this is also important. You will see here that for section number 2, you need 5 bars, number 10, while in section number 2, using B500B, you need 4 bars only. Why? Again, because of the code requirements regarding the maximum allowable steel. So if you use here high strength steel ES600, you may have an increase in steel. But of course here, you can overcome this issue if you reduce the bar diameter, okay? So in some cases, you may get the same number of bars, okay? In some cases, you may get an increase in the number of steel bars, but you can solve this as an engineer because the code requirements are mainly related to spacing, maximum spacing between bars. You can fulfill the code requirements if you reduce the bar diameter in these cases. Last two sections, large saving were achieved in section number 3 and section number 4. You see here significant saving in steel when you use the high strength steel reinforcement. Instead of 8 bars in section number 3, you need only 6 bars. In section number 4, instead of 6 bars, you need 5 bars if you use high strength steel. So mainly I included here this small table at the top mainly shows the requirements of the code regarding the maximum allowable spacing, which mainly caused some increase in the steel. So the table shown here shows the differences. At last column shows the differences between ES600 and B500B. For section number 1, no change. For section number 2, positive values means an increase in the steel. But here you got 25% increase in the steel. But again, this is because we didn't change the bar diameter. If you change the bar diameter and use bar number 8, for example, in ES600, you may end up with saving here. For the last two sections, you have saving, significant saving in steel, 25%, 16.7%. So these are the results for the one-way slab. Moving on to the 4-bay beam, we selected an internal beam. 4 bays, the beam highlighted in this layout. Span of the beam 10.5 meter, beam width is 0.4, column dimension 0.5 times 0.5 meter. The tributary area of the beam, it carries 2 meters from each side because the slab is one-way slab. So the tributary area of the beam is 4 meters. Again, the beam resists gravity loads, 1.4 dead, 1.2 plus 1.6 live. The code requirement regarding the minimum height of the beam is this expression, span over 18.5, because the one end continuous condition will control the H minimum. So for high strength steel ES600, the required code minimum height is 714. For the B500B, H minimum is 633. So here we decided to use a beam height equal to 720 to avoid the deflection issues, and we, in this case, a check of deflection was not needed because we fulfilled or we selected the height that fulfills the code minimum requirements. This is the model for the beam. Again, it's 4-span beam and the bending moment and shear force of the beam. Of course, the code allows to develop a model, numerical model, for the member considered in the level considered. So we considered an intermediate floor slab, and we developed the model for this level only, for the beam in this level only. So for the shear design, of the beam, here, according to the ACI 19 and the evaluation report, ICC evaluation report, F yield should not exceed 420, okay, for the two steel grades, okay? So since F yield will not change here, you have a maximum limit and upper limit on F yield. So the table shown here for the shear design results shows that the required stirrups and transverse reinforcement mainly is the same for the two steel grades. Although there are some minor changes, some changes in the code equations regarding to the shear, but since the F yield used in shear design is 420, so we ended up with the same shear reinforcement for this beam, mainly U-shaped stirrups, bar diameter number 10. For the flexural design of the beam, this is the moment capacity of the beam and considered critical sections. We considered here 5 critical sections for the beam, shown here, section 1 to section number 5. The comparison here between ES600 and B500B show significant saving, okay? If you look at the last column, the rebars needed. First section, for example, you need 8 bars number 16 if you design using B500B. If you replace B500B with ES600, you need only 6 bars number 16. If you look, for example, at the last section, section number 5, you need 11 bars number 16, while you need only 9 bars if you use ES600. Again, the maximum allowable spacing by the code, controlled some sections. So section number 3, you will see that you need 7 bars using the 2 steel grades, okay? But this is because of the limitation related to spacing, okay? So to overcome this issue, again, the solution is to reduce the bar diameter. If here we didn't have any change, 7 bars and 7 bars, but you can have saving here by reducing the bar diameter, okay? So again, the limitations of the code related to the maximum spacing, and the differences are summarized here in the last column for the 5 sections. All sections except section number 3, where the no difference here was observed, but for other sections, you have large saving. So 25% saving, the least saving observed here is 15.4%. Moving to the column, the design of the column. This is the column highlighted here is an internal column, and we designed the column at the ground story. So the column dimension is 500 millimeter by 500 millimeters. The column height is 4 meters. This is the height of the ground story. We designed the column to resist 2 cases of loading. Case number 1, axial compression only. The B ultimate of the column is 5,517. The second case of loading, we assume the column resists axial load and bending moment. Keep in mind that the column resists gravity loads only, because the structural system here is a building frame system. So the second case of loading is mainly from gravity loads and case of loading, because if you apply case of loading for the beam, you end up with moment transferred from the beam to the column. So for the second case, B ultimate is 5,517, and M ultimate is plus minus 200, based on the case of loading, of course. The cylinderness of the column is non-sway column. Why? Because you have shear walls here in the 2 directions, and the stiffness, according to the code, ACI 19, the stiffness of the shear walls are 12 times more than the stiffness, summation stiffnesses of all columns in the considered direction. So if you have shear walls with stiffnesses 12 times or more than the total stiffnesses of the columns in the considered direction, you can assume or consider your columns non-sway columns. So here is the design. These are the axial load bending moment interaction diagrams for the two columns designed on the left-hand side using ES600. Right-hand side is B500B. Differences between the two columns in terms of steer ratio and number of bars is shown here. Two columns are safe, of course. The capacity ratio very close to 1, slightly less than 1. You need for the column designed using ES600, you need 20 bars number 20. And for the right-hand bar, you need 24 bars. So there is saving 4 bars if you design using ES600. The points shown here on the interaction diagram are the two cases of loading for pure axial compression and for axial compression and bending moment, positive or negative. This table summarizes here the results of the column. Before I cover the results, of course, the transverse reinforcement here for the column was the same for the two steel grades. So transverse reinforcement, mainly we need bar number 10, and the spacing between the bars was the same for the two columns. So no change in transverse reinforcement. Only the change here is in the longitudinal reinforcement. So mainly in this sample designed for a column, you got 16.7% reduction in steel if you replace B500B with ES600. Now for the last structural element covered here, the design of shear wall. This is selected, highlighted here. Shear wall is the wall designed here. The dimension of this shear wall width is 0.3 meters, the length of 4.4 meter. The total height of the building is 25 meter. Ground story height is 5 meter. We designed the shear wall at the ground story. Why? Because this is the most stressed wall section. Lateral loads in the Y direction. We talked about the lateral loads. So mainly the shear wall resists dead load and live load. The dead load is 6,452. Live load is 1,628. The considered base shear for this wall, the base shear from seismic load is 16,148. The bending moment, the in-plane bending moment is 899. Sorry, the base shear is 899. The bending moment, sorry, is 16,148 kilonewton meter. So mainly the cases of loading here we considered here because the shear wall resists earthquake load. So mainly here we considered 4 cases of loading. 1.4 dead, 1.2 dead plus 1.6 live. The 2 cases of loading, last 2 cases of loading here, the last cases are the cases that include the earthquake load. And of course, for the earthquake load, we considered here, according to ASC 7, we consider that the earthquake load should account for not only the horizontal component of input ground motion, the earthquake load, but also for the vertical effect of the earthquake load. For the interaction diagram of this shear wall, again, comparison between the shear wall designed using ES600 on the left-hand side, for the B500B on the right-hand side. differences, mainly reduction in steel. The reduction in steel bars is explained here in the table. Mainly you got reduction of around 8% in steel bars when you use ES600. For shear force, again, the limits of the code of F field 420 is imposed on the two steel grades, so mainly no change in shear reinforcement in horizontal reinforcement because of the code limitations. But of course, as emphasized by Dr. Tamer, there are some room in future to utilize high strength steel in shear reinforcement, but so far we have to abide by the code limits. We have to use the F field 420. So this is the last structural element we designed and we used to compare between two steel grades. Now we will move to the second design sample. In this second design sample, we wanted just to show you comparison. What is the difference when I move from ACI 08 and move to ACI 19? What is the difference? Okay. Here, keep in mind that there are some limitations and requirements. What are the limitations? According to ACI 08, the grades specified in this version of the code mainly up to 520, okay? So you cannot use high strength steel to design structural members using ACI 08. If you use high strength steel, you have to use ACI 19. So for this design sample, we used only a steel B500B because we wanted to compare between the two codes, and the two codes only allow for this steel grade. So we used B500B only. I'd like here to emphasize that code provisions changed significantly from 08 to 19. High strength steel is not accounted for in ACI 19. Okay, so you cannot design a structural member using high strength steel with ACI 08. In addition to this, the ACI 08 may be unconservative. Okay, why? Because ACI 08 may overestimate the capacity of your structural member. And the figure here shows comparison between the capacity interaction diagram of a column designed using two codes. We used here B500B because it is allowed by the two codes. So if you develop the interaction diagram using ACI 08 and ACI 19, you will see here differences. This difference is mainly in the transition zone. Why? Because the strain changed in the ACI 19, especially in the transition zone and the definition of the tension control section, it changed. So here you will see the interaction diagram in blue is mainly the interaction diagram developed by ACI 08, while the black line is the interaction diagram using ACI 19. So if you have your column is in this transition zone, so you may have unconservative design if you design using ACI 08. So ACI 08 cannot be used to design any structural member if you use high strength steel. You have to use ACI 19, of course. So here very quickly, the 4 structural members were redesigned again using the 2 codes. We designed one-way slab, we designed beam, we designed column and shear wall using the 2 codes. So again, same models and comparison here. The 2 tables here compare between the 2 codes. What you will get if you move from top table ACI 08 and the bottom table is ACI 19. What is the difference? Actually, no difference here, okay? So mainly you will get, because here we use same steel, B500B. Keep in mind, this is the same steel. We just changed here the code. So although there are some changes in the code, but the changes in steel quantities mainly unaffected, the flexural reinforcement. So, I already covered this. Yeah, one important consideration here, we said the flexural reinforcement didn't change between the 2 codes. But if you look at for the one-way slab, you need temperature and shrinkage reinforcement. So the temperature and shrinkage reinforcement, if you move from the ACI 08 to ACI 19, you will get an increase in temperature and shrinkage reinforcement. You will get 19% increase in temperature and shrinkage reinforcement. Why? Because the minimum reinforcement in one-way slab, according to ACI 08, was 0.0015, because here's the expression recommended by ACI 08 has a field in it. While for the ACI 19, it's constant ratio. It's 0.0018. So steel ratio will not affect the temperature and shrinkage reinforcement. So now for the beam, again, we redesigned using the 2 codes, and here is a comparison between the results. Top table is ACI 08, bottom table is ACI 19, no difference. Same number of bars, same diameter if you move from ACI 08 to ACI 19, no difference in flexural reinforcement. For the design of the column, again, comparison, left-hand side is the ACI 08, right-hand side is ACI 19. Again, no difference in longitudinal reinforcement, also in transverse reinforcement. One important consideration here is the area where I highlighted using an arrow. If you look at this arrow and compare between the left-hand side and right-hand side, you will see small difference between 08, ACI 08, and ACI 19. So if your column is at this region, and you design using ACI 08, you may end up with unconservative design. So you have to use ACI 19. So for the shear wall, again, we designed the shear wall using the 2 codes, 08 to the left-hand side, ACI 19 right-hand side. We obtained the same reinforcement for the 2 shear walls. Again, I'm highlighting here the difference, a small difference between the 2 codes in the transition zone. And why? Because the tension-controlled strain limit was 0.005 in ACI 08, while for B500B, it's 0.0055. So now let's summarize the results for the first design sample where we compared between 2 steel grades, ES600 and B500B. What are the changes, potential changes in steel quantities? The changes are summarized here. you may get a saving in steel up to 25%, but be aware that some sections you may not have any difference, or your steel may increase. But this is because of the code requirements related to maximum spacing. You can solve this, and you can come up with higher saving if you reduce the bar diameter. For beam and shear walls and columns, savings are shown here. When you replace B500B with ES600, you will get significant saving in beam between 14% and 25%. In columns and shear wall, it was between 8 and 16%. For the second value engineering design sample, when we compared between the two codes, old code 08, the new code ACI 19, mostly the flexural reinforcement and longitudinal reinforcement were unaffected. But the shrinkage and temperature reinforcement in one-way slab increased by 19% when you move from the old code to the new code. So let me summarize here. I will go through the summary and limitations of our study. Any study has, of course, some limitations. So we presented here value engineering design sample to compare between two steel grades, ES600 and B500B. We used here the new code ACI 19. Why? Because it allows to use high strength steel. This design sample, we extended it to cover the differences between the two codes, ACI 08 and the ACI 19. Here we used only steel B500B because it is permitted in the two versions of the code. In our design sample, we came up with some saving potential changes in steel. But of course, I'd like here to emphasize that this is pertained to the selected structure, and the interpretation of the results is your responsibility, meaning I presented here some savings. Don't expect that you will get this saving without doing some effort. You have here a material, and this material is a new material. If you want to get most benefits of this material, you need to do some effort, okay? So you will not get the saving automatically. You have to do some effort in your design, and you need to use this material in the proper application. So this is something I'd like to emphasize it here. And we need here also to emphasize that development lengths and lab splice requirements of the code may impact the results, because there are some implications here if you add the development lengths and lab splice requirements of the code to the calculated steer areas, which were based on critical sections. In our study, we mainly calculated the differences based on critical sections. Here also for the B500B, we considered yield strength of 500 megapascal. If you use steel 420 or 460 and compare it with ES600, definitely you will get higher saving, okay? So here keep in mind that all these results for the first design sample, the values reported here, we compared between F-field 600 and F-field 500, okay? But if you compare between 420 or 460 and 600, you will get higher saving. So to conclude, these are the savings obtained in the flexural reinforcement if you replace B500B with ES600 for the slab section. For some other sections, we observed some increase in because of the code limits related to maximum spacing. We emphasized that you can overcome this by changing the bar diameter. These are the savings obtained from the flexural design of the beam. For shear reinforcement, since the code imposes limits on the F yield used in shear design 420, mainly the shear reinforcement were not affected. These are the ratios, 8% to 16% in longitudinal reinforcement of the shear wall and column when you replace the B500B with ES600. For the transverse reinforcement in shear wall, we obtain the same reinforcement, mainly because you have the limits for the code for the shear reinforcement for 20. Here also, I'd like to emphasize that high strength steel has other benefits other than the saving. Of course, when you replace the B500B with ES600, you overcome issues in the connections. We know in high-rise building, you will end up with high steel ratios in columns, so at joints, you may end up with problems during the construction. So one of the benefits of the high-strength steel is to improve placement of concrete and consolidation, of course. When we replaced the two codes, when we compared between the two codes, mainly the reinforcement didn't change, with one exception is the temperature and the shrinkage reinforcement, which increased by 16% because of the code now uses, the ACI 19 uses constant value, certain value for the temperature and shrinkage reinforcement. So with this, I'd like to thank again Emirates Steel for supporting this project, and there is a disclaimer in our report, and it is shown here. Mainly in this disclaimer, I encourage designers to look at the results and interpret these results. Don't expect that you will get this saving directly. For example, if you use high strength material in a residential or a small structure, you need to know how to use this material. A simple example of this is if you use, for example, pre-stressed structure. So when you use pre-stressed structure, you have material with very high strength steel, so you need to know where to use this new material. So mainly the disclaimer here is to encourage you to look at the results and to use this material in the proper structure and proper application. With this, I conclude my presentation, and I believe we have here a session for questions. Thank you very much.
أعزائي الحضور، والآن سنتوجه لاستراحة 15 دقائق وثم العودة.
Dear guests, please have a break for 15 minutes and be back by 1:15. Thank you.
الله يخليك احنا اللي متشكرين.
Business Intelligence Manager at Emirates Steel Arkan, for an open panel discussion revolving around the quality assurance of ES600.
Is it ولا؟ Is he think?
Make sure, okay, it's working. So, assalamu alaikum. We have received a lot of questions. So, let's start now with the first question. I think this is a technical question, it goes for the doctors. So, at design drawing and notes, we write the steel bars used in Emirates Steel Arkan ES600 or else? I think they are asking about the code. Which code?
Typically, you need to specify the steel grade. So it's based on the ACI. You need to indicate grade and then grade X. So for ES600, it should be ES600 grade 600 to be compatible with ACI. ACI code, as I mentioned, it specifies the grades as grade 420, grade 690, grade 550, and the number indicates the yield strength. In their report, the ICC, they designate ES600 as ES600 grade 600. So the wording grade 600, I think it's important to identify the grade as per the ACI terminology.
I think it's very clear. Now, for the second question is, what is the fatigue performance for ES600? Dr. Rahman, can عندك?
In our study, we didn't go through the properties of the material. Why? Because this material, the ES600, is already approved by International Code Council, and the properties of the material is well known and accepted and permitted by the International Code Council. For the fatigue properties, we didn't conduct in our study any experiments related to the fatigue. The code identifies the code, and the evaluation report highlight some limitations and requirements related to this material. So you don't need to bother yourself with the fatigue properties, because why do you need the fatigue? For me, I didn't conduct any tests for to come up with the fatigue values, but the material is approved by the International Code Council. So I hope this answers your question. I don't have information about this value. I'm not sure if Emirates still has. Yeah.
Just to add what Dr. Aman has said, in fact, we had shown in our presentation also that the fatigue properties of this grade ES600 is in line with the fatigue properties of the B500B also. It is no failure until 5 million cycles. So which is in line with the B500B, what we are using today.
So to go on for the next question, is such high strength steel rebars used in other parts of the world? Termani?
Yeah, sure. In fact, in UAE, we are just introducing this grade, but such high strength grades are adopted already in various parts of the world. USA, they have been using 550 all along. They have even gone to 690 as per ASTM A615. Also Japan, Korea, they have already used high strength grade. They have gone even up to 1,000. Indian standard, there is already a grade 550. Grade 600 is also there in Indian standard. Singapore standard also, there is exact equivalent of ES600, which is called grade 600 as per Singaporean standard. Recently, now KSA, they have also introduced grade 80 as per ASTM, that is equivalent to 550, while this 600 is slightly better than the grade 550 also.
So is it required to use self-compact RC or normal RC, doctors?
Actually, it is not, both of them are, they will work fine, but generally for self-compacting concrete, the flowability is high and better, workability is better, so, but it might be costly. So if you have a lot of steel inside, it might need self-compacting concrete. If you use ES600 as high-strength steel, as mentioned, you will end up with few number of bars, so it might not be necessarily to use self-compacting concrete, and this will actually reduce the cost as well.
So the ES600 can be used in, for example, bridges, piling, post-tension slab, and pre-stressed?
I don't think you could use post-tension cables.
Mm-hmm.
So pre-stressed, you produce deformed bars. So maybe it can be used as supplementary reinforcement, but not as cables. Because in pre-stressed concrete, we have two cases, fully pre-stressed or partially. Partially pre-stressed, we have pre-stressed concrete and steel and conventional steel.
Mm-hmm.
So if it's the section is partially reinforced, partially pre-stressed, for the conventional steel requirements, you might use it depending on the application. What are the other questions?
Bridges, can we use it for bridges and piling?
You need to check the evaluation report.
Mm-hmm. Okay. Mr. Muhammad, this question goes...
Just
yes,
to add this to this answer, Dr. Tamer. Piling, it can definitely be used because there is already one contractor who has used this material in piling, and the piling is going to start maybe within a month or so. Regarding bridges, it is governed by the ASHTO code. So, as we understand, it can be used in bridges, but till now we have not seen anybody really using it in bridges.
So, Mr. Muhammad, this question, I think everyone is thinking about what would be the cost for ES600 compared to ASTM 615?
Well, I cannot tell. I mean, that's a secret. We have to keep it for ourselves. But definitely, I mean, there is an increase in the cost when we produce ES600 compared to the B500B. And we are not willing to charge you all the costs, I mean, dear, but gradually we are trying to minimize our cost as much as possible. But again, maybe the question should be linked to the price, at which price we will price the ES600 compared to the normal let's say, Rebar B500B. And the answer here, it will always depend, I mean, on the project, because there is a benefit as it has been proved by the doctors here, and the benefit could be up to 25%. But from our side, we will not go and charge 25% increase in the prices. The increase will be, let's say, somehow, yes, there will be an increase, but just to cover the cost and to make sure that there is a benefit that can be shared by both parties, either by Emirates Steel or the contractor or even the developer.
Excellent. Is it allowed to mix more than one grade in the same element, doctors? Or money?
To mix two grades of steel in the same element, we don't recommend it for under the same action. I mean, under bending moments, the longitudinal reinforcement, we don't recommend to mix two steel grades. But in the past, of course, you can mix steel resisting bending moment and stirrups resisting transverse reinforcement. In the same project, you can, of course, you can mix. We don't see any restrictions to use high-strength steel at certain level of your building, probably highly stressed columns at lower stories in a high-rise building, while if you don't need high-strength steel at higher level, you may use different steel here, but be aware that when you use different steel, if yield will be reduced dramatically. So from ES600, if you move to 420, for example, or 460, so there is a significant difference here in yield strength. So be careful, because in this case, you should avoid a significant reduction in strength in the same story, because this will create like irregularity in your structure. So if you have the same number of bars, ES600, and then you replace this at certain story with steel 460 with the same number of bars, you will have reduction here in strength in your cross sections. So you have to be aware and calculate the strength at this level in this transition zone to avoid having a weak story at this location, because this is a kind of significant irregularity identified by the code ASCE 7, and this weak story, of course, has requirements in the design over strength factors and so on. So we don't see any restrictions to use different steel grades in the same project, but you have to fulfill and check these requirements.
So for the next question, what are the best elements to use ES600 that will give more savings?
Typically, to utilize the high strength of the steel, then you need to make, as mentioned, of course, by Dr. Aman, and I totally agree, you need to make effort in design to achieve cost saving. So it's highly dependent on the concrete section size and also the concrete strength. So if you reduce the concrete section size in general, regardless of the element, as long as you satisfy deflection requirements and serviceability, then this will result in high cost saving. I think similarly for concrete strength, if you change the concrete strength, then also this will impact the amount of steel you are going to save. So to fully utilize, then the best element would be if you have longitudinal bars under tension. So this will fully utilize the tensile strength. I mean, in terms of flexure, if you are designing flexure elements, so attention side, the ICC and the ACI allows the use of full capacity of the bar, 600.
So kindly, what's your opinion on design against BS 8110 as per BS 4449? The yield strength is allowed till 650 Newton meter, and the UAE market is mostly on BS. What's your opinion on design against BS 8110 as per BS 4449? The yield strength is allowed until 650. Up to 690. Yeah, so 600 maybe we can say is the minimum, and we can go up to 690.
The answer is dependent on the application. And you are saying that there is a steel produced up to 650, and this is not surprising. This is not surprising to me because we have steel in the States up to 690. So I mean, having 650 it's acceptable. But now, to answer your question, for a specific steel grade, for a specific property, you need to check the applications allowed by the code and the applications that are not allowed by the code.
Excellent.
And this actually applies for an ES600 and any other type of steel. For example, and this is also important, I thank you for this question. If you are going to implement ACI design code in design, then you have to stick with the bars, grades, specifications that are specified in the ACI. For example, the steel bars that are actually satisfying the British standard may not satisfy the ACI standard. So you cannot just take the bar and apply, produced based on the British standard, and then apply the ACI standard. And the opposite is also not recommended. So if you select a bar that's based on the British standard, so it is risky to use ACI standard. If you select a bar that's actually used in the ACI standard, it's risky to use it in British standard, and actually it might not be even only risky, they might not meet the specification required in the code.
So to go for the other next question, what's the main reason to produce 90 KSI rebar when 100 KSI rebar is a standard as per codes?
You are right. In fact, ASTM standard, there are two grades, grade 550 equivalent to grade 8, which is called grade 80 with a 550 yield strength, and grade 690 equivalent to 100. While in UAE, we are still at a level of 500 yield strength as per the BS. So yes, internally, we had a lot of discussion on when we are introducing this grade, what is it that we should introduce, whether we should jump directly to 690, which will be a substantial jump going from 500 up to 690, for which the market may not be ready. Also, producing this grade 690 is difficult. Okay, from Emirates Steel, based on the equipments we have, we can produce this grade 690, but nobody else within the UAE, they may not be able to produce this grade. So we went for this grade ES600 at a 600 yield strength, which is actually a sweet spot for the market where you can gain substantial benefits of up to 18-20% to 25%, whatever we showed in the presentation. And at the same time, the jump is not too high between 500 to 600, so that the whole market can cope up with this kind of a strength rebar. So ultimately, yes, maybe after introducing 600, maybe after a horizon of 4 to 5 years, we can go to 690. And in fact, it's a good question. In fact, if we see US, they introduced the 550, and they are now at a level of 690. So they are already using 690 in their projects, but a very small quantity. I would say the adoption has been very limited, but they are still at 690. So our target is also to go to 690, but maybe at a later stage once the 600 is fully accepted in the market.
So when do you expect ICC table incorporates with ACI 318-19? Any expected dates, maybe?
I think maybe we need to ask the ACI committee.
Anytime soon?
How many years, Dr. Aman, maybe?
Previously, the codes, we used to have change new version of the code every 3 years, but they changed this recently based on feedback from the designers. The designers provided feedback to the code drafting committees to increase this period between one version and another version. Yani previous version of ASC 7 was released in 2016. Current version is 22. So an ACI, previous version of ACI was ACI 14. Now we have ACI 19, a gap of 5 years. Next version of the ACI we expected in 4 years, probably 24 or 25. And there is a recommendation in the International Code Council evaluation report to implement the code, the table number 5 in the next version. But when exactly, we don't know when the code, but expected in 2024, 2025. But sometimes the code is released a little bit later, probably because of the need to implement more and more changes. So hopefully it will be released next year or the year after.
So I think this question now is repeated more than once. So most of the audience here are asking whether they can use or mix ES600 with B500B. Is it possible, and what are the impacts?
Yeah, as mentioned by Dr. Aman, and I agree with him as well, under the same straining action, it is not recommended. So, but in different action, it might be used. For example, if we have a beam, you have tension reinforcement and you have shear reinforcement. So you might use the entire flexure reinforcement ES600 and maybe the shear reinforcement B500B. But for the tension reinforcement only, it is not recommended to have 2 different grades under the same action. So I think this would answer the question.
So one more question, Mr. Muhammad, maybe you can elaborate on that. It will be in Arabic, sorry. So مدى فعالية استعماله في المشاريع الصغيرة كالبيوت والفلل؟ كم السعر المتوقع تقريبا بالطن مقارنته بالتوفير المتوقع؟
طبعا احنا we have looked at this aspect in terms of where this ES600 can be used, a high tensile grade. And of course, I mean, the more steel will be consumed in a project, the more benefit that you will see. But when it comes to a smaller projects like villas, for example, where the volume of steel hardly can exceed 100 tons, maybe the benefits will not be realized compared to a project where it will consume thousands of tons. But nevertheless, I mean, there's a saving. And we have, in fact, we have done some cases with the DAR, I think, where they are building, let's say, a huge number of villas, but the size of the villa is small. So yes, I mean, there is a benefit, and we have shown them the benefit. We have even worked with them on the value engineering designs, and it has proven there is a benefit that if they use ES600, there will be a lot of saving. Now, when it comes to prices, as I said, I mean, in some occasions you will find yourself making a huge saving from ES600. In certain occasions, you might find yourself making 5, 8, 10% saving. And accordingly, the price will be determined. I just want to emphasize on one subject here, that we as Emirates Steel, we have a number of distributors across the whole country. I mean, in Abu Dhabi, in Al Ain, Northern Emirates, الغربية. So it's really important to know that, okay, the material is available. Some of our customers, they already have the material in their stocks. So I know that some contractors, consultants, they might have this concern with regard to if we design with the material, then how we make sure that we will have the material available in stocks, or will it take time to supply the material to a project? The answer to this question, it will be available as B500B with all our approved distributors. And we have done with them already tests on the cutting and bending, and it all went, let's say it was a successful story or journey. So in a nutshell, the material is available, prices can be discussed with the suppliers, and from our side we'll be happy to support if there are any projects which will use ES600 in, let's say, big volumes.
I also elaborate on that about the economical aspect of using ES600 in small villas. It depends on the floor slab structure system. So it is very likely, even if it's a villa, the floor slab, the spans between column might be high to allow space. And in such a case, ES600 might be very economical in floor slabs. So this just to give more information about the potential use of ES600 even in small villas, but of course it should be case by case.
So is there any problems using this type of steel? Any special recommendations? Any things that they need to take care of regarding to the design and other stuff?
Regarding the design?
Yes.
I believe in our first part of the presentation, Dr. Tamer highlighted several requirements and limitations. There are specific table in the ACI code and in the ICC evaluation report. As a designer, you need to have these tables with you, and in addition to these tables, there are some additional requirements. I will not go through these requirements because it's case by case whether your structure in seismic design category A, B, C, or higher, whether you use a certain structural system, building frame system, or moment resisting frame, or a structural wall. So it's case by case. So for all types of high strength steel, there are requirements. And if you want to reach your goal to have saving, you need to follow the code recommendations and requirements. So I believe we summarized this in our presentation, and also it is covered in detail in our report submitted to Emirates Steel, and you are most welcome, of course, to have our document and presentation.
So will the municipality allow the consumers to use the new code of ACI, or they have to use the old version of ACI?
Okay, this is a good question. Do we have someone from the municipality here?
Okay, there's no one from here. So.
But of course, for me, I can briefly cover this. So far, Abu Dhabi International Building Code adopts ACI 08. Okay, Dubai now is in building code, new Dubai building code. They use the new versions of the code, AC7 and ACI. Of course, there is a need in Abu Dhabi to move towards the new codes, not only because we need to use high strength steel, but also because any new version of the code, the changes in the code is based on lots of research and experience. So why we change the code from one version to another version? Because of knowledge. So we came up with knowledge. As you see, the example that is very clear, everyone heard about in the news about the damage in the earthquake in Syria and Turkey. Based on this, we have new knowledge and experience, and based on this, design codes are developed. So of course, we need to move from the old code to the new code, but when, of course, this needs some effort, of course, and of course, we welcome any collaboration with Abu Dhabi Municipality to achieve this goal and move to the new versions of the code.
So, yeah, sure, Salim.
In fact, we had a lot of discussion with the Abu Dhabi Municipality and ADQCC, and whether there will be any kind of restrictions in terms of using E600 when it comes to projects in Abu Dhabi, and the feedback that we got from them. Yes, Abu Dhabi Municipality, they are still using the old code 08, but from their side, there's no restrictions to use E600 or the high tensile grade. And in fact, we have got all the document supporting, let's say, the approvals from these entities. So I don't think there will be a problem designing any project within Abu Dhabi using the ES600. And of course, we have the engineers here from the municipalities who are attending this workshop, and they are very well familiar with the high tensile grade, and I don't think that they will face any problems evaluating or giving approvals to a project where an E600 or high tensile grade has been designed in that project.
So last but not least.
Just
yes,
to add one more point to what Mohammed has said. Sure. The good thing is now in ADQCC, that is the Abu Dhabi Quality Council, this ES600 grade is also included in the set of codes. So which we showed in the presentation also, it is also a part of the ADQCC codes, the entire ES600 specification. So it is already available with ADQCC.
Okay, so last but not least, how we can, as the consultants or contractors, how they can convince the client at early stage that the design of ES600, one second, sorry. No, how they can convince the client at early stages to use ES600, and it will reduce the cost for 20 to 25%. And it will not be achieved across the elements and design cases of the same element. Is there any typical table showing that there are some kind of savings that maybe they can share to the clients, which they can show maybe where are the savings of the 20, 25%?
You want to answer?
No, I mean,
okay. In fact, before introducing this product itself, we have done an elaborate study with two consultants, Hatch and Robert Bird, which in fact partly we shared in the first presentation what was given. Those documents we can share with you, where we have identified element by element what will be the saving. And also, in fact, Dr. Aman's presentation very clearly enumerates his own study, where he has also gone element by element to identify what will be the savings. Also, in addition to that, we are also giving, in cases where you have the design ready, we are also giving a value engineering support, where we can take your design on B500B and show you at least few members how it is, what are the savings. So these are the way we are supporting various consultants on showing you what exactly you can gain by using this product.
Yeah, I totally agree, yes. And I believe also the owner would need to actually collaborate with the consultant and maybe, I don't know, maybe make some pressure to actually spend again, I'm repeating as mentioned by Dr. Aman, and I'm in full support of the statement. It is very likely that you will get saving. However, this requires effort from the designer. So if the owner is controlling the process, because if eventually the saving would be toward his or her benefit, then any designer, after spending effort, certainly saving could happen.
So at last, there is a small request from the attendees over here to share all the presentations and your contact details. And I can assure that anyone have registered over there will receive all the presentations and the contact details from all the doctors for any consultation in future, inshallah. So thank you all for being here. Thank you, doctors. Thank you, Mr. Mohammed. Thank you, Mr. Mani. Thank you, dear guests. And we hope you enjoyed the session today. Thank you.